Hi, this is Mr. Hubbard, and we're doing another video here. And I want to quickly cover the worksheet number 2 here. Now, in class, I talked about worksheet number 1. Or excuse me, this is worksheet number 1, problem 2 on worksheet number 1. And I want to do this one very quickly because this one, people are making this a lot harder than it really should be. So on this, I just want to go through, first of all, that this was the kind of thing that a lot of people were doing in the lab. And if you were watching what was going on with your car in the lab, then you should have got this. If you don't remember at all what was going on in the lab, I'm going to have to ask you, the labs I do are for a purpose. It's not just to prove what already happened, it's so that you can discover what's going on. And that's really important. You take the opportunities in these labs to actually try and figure out what's happening in the real world. That's why we're doing them. Not to just prove that what I was lecturing about is real. So let's take a look at this. Let's try and think about what's happening. In this case, 0 is right here, 25 is right here, and the top of the ramp is here. So it looks like what's happening is that this ball is going to roll down this ramp. And as it rolls down the ramp, our distance is going to start from a very far away place to 0. So we can actually start plotting that on our x versus t graph. And that's what we're supposed to do here. Plot these 3 graphs, then a motion map here, and the 3 equations that go with these 3 graphs. So I'm going to start here. I'm going to end here. But it's not going to be a straight line. If it was a straight line, then what we would have is a constant velocity, which we already saw. And that's not what's happening here. It can't be constant velocity because right here, when we let go of the ball or let go of our cart, it's not moving. It's 0. And down here, it's moving really fast. So 0 moving is almost a horizontal line. Fast moving is going to be a pretty steep line. And so if I start from an almost horizontal line and go down to a steep line, it's going to look like that. Never mind the little bumps there. Well, the next one is going to be pretty similar. Well, not pretty similar, but it's going to be just as straightforward to do. When we start here, it's a velocity versus time graph. Velocity right here is 0. So I can just start right here. It's 0. The ball is going to be coming towards us, and it's going to be increasing in its speed. But since it's coming towards us, it's got to be a negative velocity. So if I start at 0, and I'm increasing speed, then it's going to be something like that. So that's our velocity versus time graph. Acceleration is really just the slope of this velocity versus time graph. And since this slope doesn't change all the way down, what we have is a constant, a horizontal line all the way down the page. Let me get my horizontal line here. That's our horizontal line. The motion map, well, it's going to start far away. And it's going to slowly increase in speed. Not that slowly, but the dots are going to get farther apart as it increases in speed. And we can just draw arrows on these with bigger arrows next to each of these dots. There we go. So that shows us that it's increasing in speed all the way. Now for our equations. Well, let's do the easy one. All the way down here. If acceleration is a constant, then this equation is just acceleration equals a constant. The second easiest one, this one is a straight line. And here's the velocity graph side. There's time. So instead of y equals mx plus b, it's going to be velocity is going to equal, well, m. Oh, the slope of this line is this acceleration. So I can say a times t plus whatever our initial velocity was. In this case, the initial velocity is 0, but if I pushed it down the ramp and I gave it an initial velocity, it would start down here. This one's the trickiest, but you might remember from Logger Pro, we got this kind of an equation. It's something like a t squared equation. So I'm going to say my displacement or distance, I didn't like that, is going to equal a times t squared plus b times t plus c. I'm not going to go over all of what these means. We'll talk about more about this later. But this a is just some constant, that b is another constant, so that c is a constant. And you'll see a formula that looks very much like this when we start looking at our formula sheets, which is where I'll talk about this again. Really quickly, I just want to talk about the last three problems in here. Problem number 3, this one, you can work your way through it in the same way I just worked our way through those. We're pushing it up this hill, and we're going to assume it's not going to go all the way over. It's not going to go like that. Where does that magic disappear when I need it? So that's not what's going to happen. And so it's going to go up this ramp. We know because gravity is going to stop it and push it back, it's then going to come back like that. So we can figure out our graphs. It's going to start at 0, but then what happens to it? You need to think about what happens. Velocity. It's going to start with a positive velocity. Way up here, that's our initial velocity. Then something's going to happen to it. And our acceleration, once we have our velocity graph, we'll be able to figure out our acceleration. These 3 equations here aren't going to be different. This is still going to be the same kind of graph, this same kind of equation. When you take a look at the graph you come up, you'll understand that. Here, it's going to be the same thing that we saw with that kind of shape. And this one, acceleration, I'll bet is still a constant. This one here, the motion map, is actually kind of difficult, but you can start it. Velocity, velocity, fast, 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 slow. And then to get it while it's coming back, instead of putting dots on the same spot, you can do this. And then you can do some arrows to go along with that. In general, if you think while you're trying to do this stuff, you'll be able to do it. If you try to recite a memorized answer, it won't work. This one, you're going to have to put together 2 graphs. This part here is it going down with a motion detector up here, and then this is going to be a constant velocity. Notice this time, because there's 2 places here, we're not going to ask for equations. This one here, it's 3 graphs. This area here, it's coming towards our origin. There, it's constant velocity. There, it's going to go up the ramp and then back. So those hints there, we should be able to figure out how to draw our graphs with this. So that's worksheet number 1 for our second unit. Thank you for watching this, and I hope all your problems have solutions.